Hello, my name is Lapid, and I'm Field Application Engineer working for Micron Technology in Israel, supporting the high-tech industry, storage startups, and the ecosystem partners in the region. Today, I'm going to talk with you about the importance of QoS latency on application performance. It is a very important topic, and I'm happy to be with you on SDC EMEA to discuss about it. The agenda for today: we will learn what is QoS latency, the effect of 5 nines and 6 nines latency on the application, and we will show a Micron demonstration of QoS effect on a RocksDB application. So what is QoS latency and how do we measure it? So we all run FIO tests and measure latencies all the time. QoS latency will be the worst case latency. It is measured in percentage and in number in nines. For example, 99.49% will be a 6 nines latency. 99.39% will be the 5 nines latency, and so on. So what does it mean for us? 6 nines latency is a 1 in a million event. Out of 1 million operations, 1 will be with this latency. 5 nines latency is a 1 in 100K events, so 10 in a million. So how do we measure this for SSDs? We run FIO sweep on Q depth and take 100 million samples for each Q depth test. 6 nines latency will be the highest 100 latencies we measure in the test. 5 nines latency will be the highest 1000 latencies we measure in the test. So why do we care about QoS? The latest SSDs on the market are capable of 1 million 4K random read operations per second, which means 1 million IOPS. At maximum speed, the customer will see a single IO with 6 nines latency and 10 IOs with 5 nines latencies every second. When we talk about QoS, we talk about scalability. So here are some examples for it. Customer that will push the SSD to its max limits of 4K random read operations will see 10 IOs at 5 nines latency. Okay, so 10 IOs is not a lot, but customers usually not use 1 SSD per system. They use 10 SSDs per server, for example. So with 10 SSDs per server, they now have 100 IOs per second. And with 20 servers per rack, they now have 2000 IOs per second with 5 nines latency. And for hyperscalers with 20 racks per solution, they will hit 40,000 IOs at 5 nines latencies per second. So this practically goes up to the math of a very, very small percentage of a very, very large number is a relatively large number itself. So the application will need to deal with this kind of latency. Let's take another example of a more real-life workload, 70-30% 4K random read, and SSDs are capable of 400K IOPS in this state. So this leads us to 3 reads at 5 nines latency per second. And if we do the math, we end up with 12K reads at 5 nines latency per second. So an application that will not be able to handle this type of latency will eventually show the end customer an effect of slow loads or dropped web pages or failed transactions from time to time. So let's take a look at this graph, for example, for QoS. This is a 5 9 QoS, 1 in a 100K event, 4K random read 70% with a QDEP 1 to 128 measured on 5 different SSDs. And the way to read this graph is the y-axis is the read latency with millisecond, and the x-axis is the IOPS. So as far as we go to the right on this graph, we need to stay at the lowest latency, and this is the best QoS scenario. So if we look at this graph, we can see that SSDs C and D are acting with the best QoS at lowest Q depth. However, when we increase the IOPS, we see that SSDA increased the IOPS on this QoS number and even exceed SSD-D and reach higher IOPS at the same QoS ballpark. Let's take a look at 6 nines latency. And here we measure again. We can see that at higher IOPS, SSDA reaches 15% more IOPS than the rest of the SSDs with the same QoS latency. So far we saw a synthetic workload on an SSD with FIO SSD latency. Now let's talk about application level latencies. So we took a RocksDB, which is a high performance, low latency embedded storage engine, and a key value database. And we used it because, for example, hyperscalers like Facebook maintain it for their backend systems, and it's a key component of self-storage systems. So the way we tested the QoS was on an AMD Milan system with the 7.68 terabyte SSDs. We used Yahoo Cloud Serving benchmark and the 50% read, 50% update workload with a 1 terabyte database, 4K byte record size, which is practically 2 terabyte on the disk space. And in this situation, we measure application operations per second, which take into account the DRAM latency, the CPU wait time, and the overall time that it takes to execute an operation on the database. So the drive QoS will be a major component on this performance. Quick disclaimer before we dive into the details of the test. The actual performance of the SSDs may vary between systems and based on the SSD firmware. And all of the drives were tested on the same test system with these characteristics. So in this example, we see a read-heavy workload on 4 SSDs that were tested. This is a 100% read, YCSB performance, 4 nines latency. And this is a 95% read, 5% update, 4 nines latency. And we can see on both cases that the SSDs are acting practically the same. There is a very minor difference of few milliseconds of latencies between the SSDs under this test. Now, when we switch to a mixed workload, we suddenly see one of the SSDs, SSD-B, that act with a different QoS profile. So let's zoom in to this in order to understand the impact of it. So SSD-B actually reached 10% higher YCSB operation per second, which is a good thing on the one hand, but if we consider the latency, it takes 2.5x higher latency than, for example, SSD-A. So if we isolate SSD-A and SSD-B in this graph, and let's understand the impact on the customer measurements. Customers usually have their own SLA measurements for their solution. And in this example, we use 15 milliseconds as an SLA measurement. So we see that at 15 milliseconds, SSDB reaches 23K operations per second in the database. Above that, it will have issues and the customer will notice it. SSDA, in this case, will reach 45K operations per second in the database. So it's 95% increase in operation per second, which is meaningful for the overall application performance. So the takeaways from this session: QoS latency measure the expected highest latency from the SSD. QoS latency can affect the overall workload and the application performance. At scale, 5 nines and 6 nines latencies become increasingly common and impactful. This is particularly true for hyperscalers, as we saw. And the better QoS can allow customers to meet their workload SLAs, as we described, which is an important metric. Thank you very much for attending this session. I hope you enjoyed it.